All right. Thanks, everyone, for joining, and welcome to another edition of the Berkeley Programming Systems Summer Seminar Series. Today, I'm delighted to introduce our speaker, Junwen Yang, who is a fourth-year PhD student in the systems group at the Department of Computer Science in the University of Chicago. So Junwen works with Professor Sean Liu on the performance and scalability problems in data processing and data analytics systems. So I first, I think, met Junwen in ICSI in 2019 when she gave a talk at ICSI on the performance optimization of database-backed web applications. And I believe that paper won the ACM 6soft Distinguished Paper Award. And Junwen has also won an award at the Splash 29 Doctoral Symposium. Has been doing a lot of cool work since then. So I believe today's talk is based on her upcoming ICSI 2020 paper on managing data constraints in database-backed web applications. I'm really excited to hear about this research. So thanks a lot, Junwen, for volunteering to give this talk. Over to you.
Thanks for Rohan's introduction. I'm Junwen from University of Chicago. I'm a fourth-year PhD advised by Sean Liu. I'm working on the performance and correctness problems of database-backed web applications and other big data softwares. So I'm glad to introduce you my work on managing data constraints in database-backed web applications. Feel free to interrupt if you have questions during the presentation, and we can also discuss about the problems after the presentation. So to start with, seems I cannot press. Okay, first of all, for data constraints, we're saying that they are often associated with the data to describe their properties in modern softwares. For example, in this given web page, it's a sign-up page that you can create an account. You can specify your username, email address, and password. We can imagine that the username might have a maximum length for the constraint, and also the email and username across the application should be unique because you don't want to run into others' email or username. And also the password might also have a minimum length requirement for the security concern also. These are all the constraints that can be specified the data properties. Also in database side, the constraints are also a popular concept. People can use SQL queries to create constraints for data. For example, I create a table called users and I set the username type to be a variable char 50. This variable char not only specifies the type of the username, but also specify the maximum length of the username, just as what we have seen in the front end. Also, I can use this outer table add constraints to add a unique constraint on the email. As a result, I have get a users table that it has different constraints on different fields. So for web applications, they have large amount of data to process, and the data are used in multiple layers. Not only for the front end we have mentioned, but also in the database we have mentioned. In between the front end and database, there will also be application logic, which will handle the field and specify different constraints on it. At the same time, this type of applications, they face frequent upgrades and they need to migrate their data often. For example, my user table could change to another type, that the variable char 15 changed to 20. So the maximum length of this table has changed, and previously I does not allow, it's not allowed to be null, but later on in the new table it has been allowed to be null, and it may have added another new type of field called nickname. Not only the database could change, the application logic and the front end could also change during the evolution. So all this large amount of data and used in multiple layers and all these migrations together makes it hard for the real developers to manage the constraints correctly. So we can look at these examples in detail. The front end has used this input max length, which is HTML tag, to specify the maximum length to be 30. And in the database side, we have used a variable char to make it 15. Also, in the application logic, we take the reals as an example. It has used something like validate length of, which is a specific validation API to specify the maximum length of my username to 30. As you can see that the database constraints are different from those are specified in applications and also frontend, which could cause problems because when I, as a user, want to create an account, I specify my username to be 16. Don't count, this name is 16. My length will be 16 username. And then I input the email address and the password, and then I click the create my account button. What will happen? Because it exceeds the database limit of the maximum length, so my page will crash and I get some user unfriendly error message, which makes very frustrated because my field content loads at the same time. So this is a very bad experience for end users, and which can actually be avoided just by changing the constraints to the same one under different layers. So in our work, we firstly want to understand that how real-world constraint problems looks like and what caused them. And then after learning that, we also want to tackle them to say whether we can do something to make it better. So to understand the real-world constraint problems, we did some issue report study. And then to tackle the real-world constraint problems, we have automatically extract some constraints. So our methodologies for application selections, firstly, we choose 12 Rails applications from GitHub from 6 popular categories. For example, the online shopping systems, project management systems like GitHub or GitLab. And then we have the issue selection problems. We randomly sampled 114 issue reports related to the constraints based on the keyword search. We use the constraints, incompatibility, or some other similar keywords to search the reports, and we manually check them. And for the constraints, in the latest version, we have used abstract syntax tree to match the constraint API to extract all the constraints in the latest version of the applications, which results in 7,000 constraints in these 12 applications. It's clearly a very large number. So to understand the real-world constraint problems, we have studied that 114 issue reports, and we categorized 4 anti-patterns from them. We call them where, what, when, and how. So we will introduce them one by one. So for the where constraint, where issues, they happen when constraints under different layers conflict with each other. It could be the constraints in the application level are looser than those in database level, which is the example we have seen before. The application specify a larger maximum length compared to that specified in the database level. And the result has also been shown that the page will crash with unhandled database error. You might ask, is it better if my application constraints are stricter than those in the database one? Actually not. When constraints in the database are looser than those in applications, it will also have problems. So in this example, which is an online shopping application, I have a line item. And in the application level, I specify that it must have a variant. However, these constraints are not specified in the database, which allows the admin go to the database and issue some SQL queries to delete the variant. What will happen? Because my variant is deleted, the application will call the line item.variant.order will actually throw an error because it's null. Null value does not have an order. The result is the same. The page will crash with unhandled application error. So which tells us only the constraining application layer and database layer are the same one. They will not cause problem, but either way, there will be different types of problems. You might ask, is it possible that admin will go to the database and delete the data? We have seen several cases in the spree applications. It's not only the administrator, it's also possible that some bad users, they could also destroy your data integration by go to the database and manipulate your database. So to enable this weird application not to happen, developers need some tool support to automatically help them enforce these constraints happen across layers. It's hard to achieve this by their manual efforts. And this type of issues covered 24 issues in our 11 and 14 reports. And for what types, the what issues happens when there is a mismatch between what purpose the data is supposed to be used in the application and the constraints imposed it. So it could be the conflict with the user needs. Sometimes the users are picky. They sometimes in the later version want to relax existing constraints. We have seen 10 issues that users want to change my length constraints from a smaller value to a larger value. So as a result, for this type of constraints, like length, or it's difficult to have one setting that satisfies all the user's needs. It would be helpful if refactoring routines can be designed to turn a fixed setting to be a configurable one. And another type is more interesting. It could happen when there is conflict with application needs. That conflict could be the type conflict, case sensitivity conflict, or the boundary value. We can also look at the examples here. So when Redmine, which is a GitHub with similar applications, you can use it to manage your project. And it uses a regular expression, D4, D2, D2, which can specify my data format to be YYYMMDD. However, if I import something like 2020, June 32, it will still tells me it's valid. However, it's not a valid data type. So just using a regular expression to set it as a constraint for a data type is actually not enough. Another type is related to the case sensitivity. When my username has a unique constraints across the application, and I think it's case insensitive, which tells me that the lowercase Bob is the same person as uppercase Bob, which means if I register use uppercase Bob, then you can never register using lowercase Bob. However, when they retrieve them, they assume them as case sensitive, which means at this time, uppercase Bob and lowercase Bob are different person. As a result, for the end user, if I want to send a message to Bob, but he register as uppercase Bob, then I can never send message to him if I use lowercase Bob. So these types of bugs, their symptoms are really subtle compared to what we have seen in the weird type, because it will not crash the applications, but it will affect your user experience because it makes the way you use the applications more complicated. And then we look at the when type. The when edit patterns happens will upgrade your application. You have some newly added constraints, or you have changed some requirements of the constraints. For example, you have previously length constraint at 30, then I change it to 20. Then some of the old data that does not violate the old constraints will violate the new constraints. We also look at the GitLab example. So their version 9.4, they have added a new field called HTML. Actually, it's HTML text. I just abridged it. And in the now settings, they allow it to be now. So you can set this HTML to now. It's no problems happens. So users might just insert a lot of records which set the HTML to be now. And in the version 9.5, what happens here is they change the now requirement to be null. This time, it does not allow this null value to be exist in this column. During the upgrading, I need to do the data migration, and the migration will fail with the database not non-violation because my data that set the HTML to be now between version 9.4 and 9.5, they violated the new constraints that introduced in v9.5. And this type of bugs prevents you to use your applications to upgrade, which just is not the ideal case for the application. And for the how patterns, it is more related to the user experience. So it's how the constraints checking results are delivered. The issues happens when the error messages associated with the data constraints are not displayed, or the default messages are overridden with some uninformative generic messages. So for example, if I created my account with a password of length 6, in this case, instead of being told that I failed to register, I'd rather be notified that my password is too short, or even more detailed case that my password is 6 and the actually requirement is 8. You need to set your password at a minimum length of 8. So like 20 issues are related to the checking results are not properly delivered to the end users. And to tackle these problems, we handle them anti-patterns by anti-patterns. For the where anti-patterns, we first collected constraint statistics. So we have a lot, our data shows that there are indeed a lot of constraints for each data field, and also the fields with constraints are a lot. This illustrates that it's hard for developers to automatically to do these things right because the number is super huge. And then we did a very detailed breakdown of the layers where the constraints are associated. So 76% are in database and 23 in application. For front end, there are only 1%. From the distribution, it's clearly that a lot of constraints in database are not associated, are not specified in application because 76% are a lot bigger than 23%. And then we detailedly compared the constraints in database and application. So we check the same field and the same type of constraint, whether they exist, or if they both exist, whether their value are the same. Our results show that there are 1,000 more string length constraints in database. They are not specified in the application, which will cause the page crash, as we have seen before in the motivating examples. And also for 100 constraints, their associated fields are not used in the application anymore, which means that there are a lot of fields in the database are useless. This will not cause the functionality problems, but brings extra effort for the maintenance. And for the applications, we also check some, there are also 24% of them are not in the database layer. In the detailed cases, 88 fields required to be unique in the application. They are not so in database. So it's easy that someone go to the database and ruin the data integration by adding someone with the same username. If the username is unique, then you got 2 usernames that are not unique in the application side. And we also checked the detailed requirements of the constraint that we have found 133 conflict in the constraint requirement with the same type of constraints, but different values set. And also for some inclusion, exclusion constraints, this type of constraints, they have specified a block list for the value, and they are not in database also. And to tackle the when problems, we also collect some data. So for how often do constraint-related changes occur, we have compared the neighborhood versions to compare the constraints specified to check whether during 2 versions there are constraints changes occur. And our data shows that there are 49% of the versions have changed or added constraints, which tells that this type of constraint change during evolution is really frequent. that's why problems could occur, because it's also hard for developers to automatically handle these situations on their own. And in terms of what triggers the changes, we have categorized them into 3 types. One is add columns, which we say that the constraint has been added to they add a constraint to a column, but that column is also newly added in this version. So we call them add columns. It's not add column, but add constraint to a add column. And then it's add constraints. This type of constraints have added a new constraint on some columns that existed before. And another is change detailed requirement of constraints that existed before. We call them change constraints. And we have shown their detailed breakdown here. So we can see that for add constraints, which this type add constraint to a column that existed before, they take up 13 to 67%, which means that constraint addition is often developers' afterthoughts. So in between the version, before the constraints are imposed, there are a lot of data that might violate these constraints are actually imposed into the database. We don't know how many, but they just allow the data which violates the constraint to be imposed into the database. And then to tackle the constraint problems of the what and how, we have automatically detected 19 confirmed case sensitivity conflict. So they have save it as case insensitive, but use them as case sensitive. We report them to the issue tracking systems, and they just confirmed, and some of them are already merged into their code base. And for the how anti-patterns, since they are caused by the error messages are not correctly delivered to the users, we have developed some new gem which can generate better error messages for the end users to say and to understand what they have done incorrectly during creating their account or submitting other forms. Yeah, here comes to the conclusions. We conducted the first in-depth study of data constraints in database-backed web application, and we have categorized 4 anti-patterns for data constraint issues. Also, we have developed a static checker to detect the data constraint issues and got positive confirmation. Our efforts to detect these constraints issues are actually very preliminary. We can still we expect a more sophisticated way to achieve this. And for the future work, during the constraint analysis, we actually find that some of the constraints can be used to improve the performance. So for example, if there is a length constraints, then when I specify when I create this variable char type in the database, I have a maximum value, which compared to the previous non-limited value, it will save some space. And also for some inclusion and exclusion constraints, which specify a range of the values, I can change the string type into some enumeration type, which can also save the space and probably will speed up the queries. And also, we want to understand that the database schema and application code co-evolution. So sometimes we have seen there are fields in the database are never used in the application anymore. In this case, we actually can help them to delete the tables fields in the database set to help them have a consistent application code and the database schema. We also see case that they have deleted a field, but still referred in the application code, which will affect the application's functionality since the deleted fields cannot be referred actually. And also for data constraints problems, we can extend them to other types of applications. For example, the distributed systems, they also have a lot of persistent files and different type of messages they need to manage in their formats. That's it. Questions?
Thank you.
Thank you.
Thank you.
If anyone has any questions, you can feel free to unmute yourself and ask question. Thanks a lot, Junwen, for that talk. I can maybe start off with the question. Okay, oh, sorry, go ahead.
Yeah, so I was just going to ask. So I saw that do you think any of your conclusions are particular to like Rails as the application language? Is there a reason why you looked at those projects in particular?
Yeah, that's a very good question. We chose Rails because it's most popular ORM frameworks, and to prove that the generability of our work, we also we also collected some issues from Django's, which is another type of ORM frameworks. We found a similar distribution of the issues that we have found in the Rails. Yeah, and also they have the same. They share the similar way of managing the constraints. That's why we choose Rails as example, but it does not specify to Rails. Should apply to all the web applications which use the ORM frameworks.
Cool. I'm guessing maybe the static discovery needs to change in between the static checker you were mentioning.
Sure. The static checker currently only applies on Rails, but you can just they're just implementing details. If you want to you use them in the Django's or Hibernate frameworks, you just need to match their API. They have the similar API, but the detailed semantics are different. Yeah, yes, you're right. We have to, if we want to apply on other frameworks, our checker need to adapt to other frameworks syntax.
Cool. Thanks.
Thank you.
Yes, I also have a question related to some of the data that you collected. So my hypothesis would be that developers would usually try to maintain backward compatibility of their systems. So if they were trying to make a change, my guess is just a guess, I have no idea if this is true or not. My guess is that there would be more changes where someone would want to loosen the constraint, right? We have like username of length 10 and now I want to allow username of length 12. Instead of doing it the other way around and saying, I now want to shorten all usernames because that means I might affect existing users, right? So did you notice such pattern? Did you notice whether the changes to these constraints that you analyzed were more about loosening the constraints than making them stricter, or was that not something that came up?
Yeah, we have seen cases that people want to lose the constraints. It happens most basically we put them into the what anti-patterns because it conflicts with the user needs. They will not cause the problems. They will not cause a page crash, but they are indeed the users their wish. So as a result, we think that we'd better make some of the constraints like length constraints or those which is hard to set. We want to create something to make them configurable. That's the ideal case, but we haven't started to do that.
All right, thanks.
Any questions?
Any more questions? You can see some.
Hi, this is Angel. Hi, Junwen.
Hi.
Nice talk. Thanks.
Thank you.
I had a question. What kind of types are you dealing with in terms of?
What kind of types? What?
Is it mostly? Is it mostly strings and numbers, or are you also dealing?
Actually, what we're dealing with, so there are different APIs that can be used to. Sorry, let me check. That we have the APIs that we have all the APIs that can be used to check the constraint, set a constraint. So in the front end, what they use it to do is they use the input tag to set the maximum length or regular expressions to check the constraints. And also in application server level, they have the built-in validation API. You can set the format of the string and the length of the numerical values or the inclusion, the range of values for the constraints for the field. And also in the database server, it could create a constraints through their migration API, or they can create it through them outer table queries. When we extract the constraints, we only care the bold version, the bold API that can extract constraints. So for you can also create constraints using JavaScript in the front end, but we don't analyze them. So they could basically we don't have a breakdown of the types of the value of the fields. It could be length, it could be the string, and we have length and format for them. It could also be numerical values. It has a maximum or minimum value. So yeah, that's a good question. We can later on check how is the distribution of different types of those values. Yeah.
Thank you.
So following up to Angela's question about types, I was curious whether that has any connection to some of the future work that you mentioned about database and app co-evolution. So for example, could you, perhaps if you're not limited to using Ruby, or maybe if you could extend some of the framework in which you can develop these apps, could you perhaps use smart type systems that sort of are aware of the constraints on fields that are being used in the database or that are being taken in from the front end, so that you could have, I guess, the same constraint throughout? Like, what are potential solutions to co-evolving applications and the database in the front end?
Oh, that's a good question. Actually, we're still checking how we're going to do that. I think smart types are good ideas on those different fields across different layers. Currently, we talk about co-evolution. It's not that related to constraints. Actually, it's more like I have renamed something, but it's still used in the applications. It's like this type of schema, database schema, and application code. It's not that related to constraints when we are thinking about the co-evolutions, actually.
Okay, cool, thanks.
Yeah, but definitely we can consider the smart types that can enforce different constraints across different layers.
Also, I'm curious if you noticed any issues relating to constraints that exist on the front end but not on the application, because I would assume that if you have constraints on the front end, like a user who wants to circumvent those constraints can just do that by manually crafting like a request or something, right? So like the front end constraints are just UI elements. They're not actually constraining the data in an application.
Yeah, that's a good question. So actually in our issues, we didn't find that, but when we analyze the source code, we find that there are some inconsistency between front end and database or application. But because the front end only occupies like 1%, as you see from the distribution, so our analysis didn't focus on that more. But we do have one interesting cases in front end is previously when you log in, they do not limit the length of your password. So, but later on they think, oh, I want to increase that to 6. I only allow you log in with password longer than 6, which means that a lot of people previously create a password with length 3 or 4 or 5. They are no longer able to log into the applications because your login password fields have increased from 0, from no requirement to some length requirement, and people with short password cannot log in, and they will give them some error message saying your password does not comply with the format, and that's kind of insane because previously I can log in and currently just tell me that I cannot log in. Yeah, that we have seen some interesting issues related to the front end constraints.
Okay, yeah, that's cool. That's a very interesting kind of issue.
Any other questions?
I'm also curious, in your future work, you mentioned that this can have applications to improving the performance.
Oops, looks like he froze out.
Yep. Oh, kind of. Yeah, you just break out for some minutes.
Oh, sorry. I said that I noticed that in your future work, you also mentioned that you could use some of this information to improve performance of the performance improvement to data constraints. So I was wondering if you had any comments to expand on that.
Oh, sure. So we have some examples saying, so for example, you have a unique constraints on my username. And previously when I retrieve my username, I will say where my username equals some parameter. But currently I know it's unique, then I know it at most will return one value. So I can add a limit one in the end of the query. So which will stop the scan when I got the first username. I know that my SQL will do that. So if I have a limit one, I will stop scan once I met my first requirement. And secondly, we could also do something like we said inclusion constraints, which is like I specify a whitelist for my value. So say my username can only be chosen from A, B, C. So at this type, I can change. Previously, my type of username is the string, but currently because I know it's a limited array, then I can use either enumeration type or some integer type, and then they can save the space. And because of they just are easier to, so string comparison is much cheaper than is much expensive than int comparison. So my query could also improve the performance, and there will be some other type of constraints which could be used to improve the performance.
Yeah, that makes sense. All right, cool. Thanks. So are you intending on pursuing any of these directions in the near future?
Yeah, we are currently doing the performance improvements through the constraints now, and for the constraints in other types, we're trying to say some other applications. Yeah.
Right, cool. I'll look out for that work.
Thank you. Do we have other questions or discussions about the future works? Also welcome.
You can also type your questions if you.
All right, well, if you don't have any other questions, we can perhaps end at least the recording. And if you just want to unmute and say hi later, we can take it around for a bit. But thanks a lot, Junwen, for this great talk. Really enjoyed it. And I guess you'll be presenting this work at ICSI as well next month. Yep. So good luck on the presentation. So thanks a lot for the talk. And thanks everyone else for joining. See you next week.
Thank you.